Hello everyone and welcome to Module 4 in Data Science Languages. Module 4 focuses on indexing, grouping, and iteration. So jumping straight in, our agenda for today will go over Module 4 at a high level, including the reading, talk about Python and R, and then we'll talk about Deliverable 4. So Module 4 talks about indexing, grouping, and iterating. And these are kind of common patterns that you'll do in data science. So the basic idea here is to utilize those core programming techniques so that you can do analytics outcomes. And in order to do that, typically speaking, you have to deal with things like indexing, grouping, and iterating, along with filtering. And we'll talk about all those things as we move along. We'll talk about the differences between R and Python, how they each approach each of those three things. Talk about the various differences and how they somewhat or somehow are similar. And then we'll talk a bit about this Deliverable 4. So you're reading in the Python book, read chapter 10, which deals about data aggregation and grouping operations. And that's basically what we're talking about here is rolling things up, so doing aggregation, and then grouping on them and potentially with the intent of doing analytics of some form. In the R book, read chapters 4 and 5, which deals with the same sort of topics. So in grouping, it's kind of a fairly simple thing, although if you've not done a lot of analytics work before, maybe not so simple. But if you think about it in terms of like SQL, which is a very common query language utilized in a lot of places, you use the group by clause on an expression that basically says, take all the things that match all my other criteria, and then basically combine them together to form a set, and then perform some sort of a mathematical operation on that set. And so we do that by essentially almost like sorting them together in a certain way, doing some math on it, and so on. Inside of R, you have the Doppler library that's done using pipes, and we'll talk about pipes here in a moment. And then Python kind of follows the pattern of split, apply, combine. And that's the basic kind of sort of approach that's utilized where you take your data, you split it up into various pieces, you do some sort of a transformation or application of a method of some sort to that, and then you stick the results back together. So what's a pipe? So in simplest terms, here's a DOS pipe at work. This is our command prompt. I guess I'm showing my age by referring to DOS. So what that does is takes the result of one command and runs it through with the up and down bar, runs it through another command, in this case more. So you're taking the results of dir and essentially funneling it into another program, in this case more, which is something that basically lets you scroll through a file a line at a time. Excuse me. The basic idea, though, is to be able to chain together the output of one operation and turn it into the input of another. And you do so without creating a name, assigning it to a variable, or even potentially storing it all in memory at the same time. And the example of a DOS prompt is just as it's to show you at a command prompt something that is essentially the same sort of concept. So moving into, we'll revisit pipes in a little bit, but moving into the Python part of this conversation, we'll talk about this group by using a split, apply, and combine sort of a methodology or approach. The group by is the idea of basically doing the steps as outlined below. You take it and you split the data based upon some criteria. So whatever it is that's matching what you're looking for, you apply a function to each of those groups independently, and then you combine that together as an overall result. Interestingly enough, this isn't all that far away from something called MapReduce, which we'll talk about in subsequent courses on big data technologies. It's that basic idea, and that's likely where they may have found it, because that whole apply sounds a lot like a map function, so to speak. So, and then the reduce sounds a lot like a combine. So those two things are kind of similar. Grouping in Python. So here's working through an example with cars, which is a well-known data set. I'm reading it in to a data frame, taking a look at it. Then we're going to do some filtering. So I want the ones that have more than one carburetor, and that gives me back just the ones that have more than one carburetor. And then I may also want to do a group by with the aggregate. So I'm basically saying, of those cars that have more than one carburetor, group by cylinder and then aggregate across miles per gallon, horsepower, and the time in the quarter second. And basically doing a mean of those, or an average of each one of those. So you can see the operation inside of the brackets, and it's a mean. It works well if you want to do it on all the columns as well. So in that case, we're basically doing a group by on cylinders, and it's functionally essentially the equivalent. So doing the split, apply, and combine sort of approach, similar concept. We're loading the IRIS data set, taking a look at the first 5. In this case, then I'm also selecting some throughout. And so here you're basically, that's basically doing picking 5 or so in the middle, and then 10 or 15 at the end. And so here we're doing a group by on species. So basically what that's doing is combining together each one of the records that has the same species, and then essentially just adding up the values for all of those columns for each one of those different types of species. A very simple way to do it. You can also then go through and pull out a particular column that you're interested in, and maybe only do the sum on a particular column and on a particular species, and so on. So the basic idea here is to do a fair amount of being able to do this aggregation on the fly. I'm going to go off script, which is always a great thing, and open up a notebook and see if we can run through the same thing, assuming I can find it in a reasonably quick fashion here. Should pop in a moment. Maybe I have to actually click. It's always risky to go off script, but I think it's worth it so you can actually see this in motion. Loss for my Chrome. There we are. Drag this over onto this window and go to that URL. Navigate down to the appropriate location. And with any luck, it's what I just showed you. And of course it's not. So we'll revisit that at the end if we have time. So moving on to the next element of the conversation. So here's an example of doing the group by using the def-ply, data frame ply, and Python pipes. So go out there and you can do a fair amount of reading. The Towards Data Science article there, pretty good one, that talks about doing piping in Python. So similar sort of concept, load the thing into the data frame, and then we use the two greater thans to do the piping. So what that's doing is taking the data set of empty cars, piping it through a select statement, and pulling out, in this case, X is essentially the current item that we're talking about, and we're selecting on that those 3 columns, cylinder, miles per gallon, and quarter second, and then we're piping that through to another command so that we can see that run against the subsequent command. And it's very much similar to what I did back with the DOS prompt. It's just that we're doing it inside of here with essentially operations. So you've got a data frame, empty cars, you're sending it to a select, then you're sending it to a mask, then you're sending it to a group by, then you're sending it to a summarize. The mask is essentially filtering it, so it's taking out the ones that match the criteria of got more than one carb. Then we're grouping it by a cylinder and so on, and then producing the output of each of the things that along the way. So group by cylinder, and then calculating the average mile per gallon of the things with more than one cylinder, and then we're showing those cylinders as well. So it's essentially the same functionality that we did earlier with some of the others, but it's doing it using this sort of piped approach. The reason that might be desirable is that, first of all, you're not creating particular sets of variables along the way. You're taking something from a source, you're pushing it into an operation that in turn pushes it to another operation. And so that's kind of the beauty of piping things together, is that you can then send them through kind of like a pipeline, if you will, of operations. And once, it may look kind of weird to you now, but once you get comfortable with it, it's actually pretty easy to read. You can say load it in, send it to the select, send it to the mask to filter out the ones you want, and you can see the results of that. And then it also allows you to iteratively sort of build it, kind of like what I've done here. And then once we've done the mask, we've selected and we're masking, then we want to do a group by, and then we want to do a summarization or summarize. So we're organizing it by cylinder, and then we're on that set of things that are then grouped, calculating the aggregate value, in this case the average or the mean of the things that match each one of those buckets or those criteria. So pretty cool, pretty interesting, pretty compelling, and also it's kind of declarative in nature. You're very much saying what you want to happen. The specifics of how it gets done, you're not as worried about. And that's one of the beauties of things like Python. So as kind of enumerating the stuff we just talked about, greater than, the two greater thans together is the pipe, and that's what says take this from one thing and send it to the next one. Selects picks the column, very much projection if you're using SQL terms, or that's technically relational algebra terms. And then mask is a way of filtering based upon some criteria, similar to a where clause if you were mapping it to SQL. Group by does kind of what you would say. It's similar to a group by in SQL, which is basically grouping it based upon some criteria. And then summarize is used to create aggregates across the particular columns you're interested in, potentially introducing aliases as well. X is just something that is thrown in there so that you can reference to the current thing you got in. There's a historical reason for X. We won't go into all that, but it basically is just being used in this context as a placeholder. It's saying I load empty cars into essentially something. So it's been loaded into that data frame. I take that data frame and I say pipe this data frame through a select statement. And I need some way of saying what are the columns I want in that thing. So X is essentially the current row in the data set, right? And then you take, or the data set itself, and then you take a particular set of columns that you want from that, and then you run it through the mask, which is again doing a filter where the carburetors are greater than 1. Yeah, so I'm not sure what has a carburetor that's less than 1, but could exist. I guess a single carburetor, like motorcycle or something. And then you group by the number of cylinders, and then you summarize, introducing an alias, which is that average miles per gallon, using the mean function off of the MPG column on the X, the current data frame that we're working with. So that's pretty much pipes in a nutshell. Pretty compelling, pretty interesting. There's other things like that in other programming languages. Some of them are very similar sort of syntax. But it may be unfamiliar to you. So if it is, the only real way to get familiar with it is to play with it, learn what it's doing, and you may get to where you see the beauty in such things. So moving into R, similar concept. So what is the percent greater than percent? And the short answer is it's also the pipe, similar to the greater than inside of Python. Not too sure why it has to be something different. Maybe it's who wrote it, or maybe there's a reason you can't do the greater than may have meaning inside of R as well. Sometimes that's used for bit manipulation. I'm not sure about this particular case. It's defined in the magrittr package. It used in Dipler, and the goal is to basically simplify the code. Similar concept as what we just did in Python, but it's doing it in a way to where you kind of can change things, train them together in a way where you can manipulate them, move them around without it breaking, is the basic idea. So you on the screen you have 3 different approaches that I've kind of been summarizing. One of them is a nested approach where you're basically nesting functions. This is a function-oriented sort of call approach. Some function-oriented languages, this is how you would have to do it. And you can see that basically what it's saying is that you arrange, summarize, group by, filter, and return a particular thing that you're interested in, calculate the average, and give and you want to do so in a descending fashion so that the largest will be first. Another approach to do that same thing that's perhaps a little cleaner to read is to use multiple objects. So you essentially assign A to the first step in the process, which is to filter. You assign B to the group by on the filter, and you'll assign C from the results of the summarize, and then you're going to do the arrange and also say that you want it to be descending and print the results. The reason those two are different is kind of the nature of the call stack. You're essentially doing the operation in the nested approach on the way back up, so to speak. So you have to go down to come back up, and so that's the reason why they're kind of you're filtering at the innermost level, then you're grouping, then you're summarizing, then you're arranging. So they're exactly opposite, and that's because of the way you're doing the traversal of the call stack. Another approach that may be simpler to understand is to utilize the piped approach. So similar sort of thing. You're basically saying pipe empty cars into filter and filter out the carbs that are the vehicles that only have one or more carbs or more than one carbs. Take that result, pipe it through group by, pipe that through summarize where you calculate the aggregate of mean, then you arrange them in descending order. Pretty much the same sort of thing that we did in the other one. So intuitively you can tell what the intent of those order of operations are. That's less obvious with certainly the nested approach because that kind of seems backwards if you look at it, right? But that's because of the nature of how the whole call stack works. So definitely an interesting sort of thing. Definitely worth understanding the concept and how it works. You may or may not find yourself using it. Similar sort of approach is mutate, which is a way of adding new variables or functions of existing variables, kind of like feature engineering is how you'd probably want to think about that. Select is a way of doing your projection of what columns do you want or what attributes. Filter is a way of doing essentially your where. Summarize is doing your aggregate or your group by, and then arrange is controlling the order of the sort. Or is used to sort the values, and in particular if you want to control their order, which is probably the point of it, you may want them descending versus ascending. And so that's basically that in a nutshell. Here's grouping three ways, kind of like what you would get on a cooking show. One is loading it in, then piping it through, sort of a variation of the two. So that's piping it through a summarize and then getting back the results. Another approach is very much the nested approach. And then if you do the nesting approach, would want to remove the variables that you just introduced. And then a pure piped approach, similar to the last one that we talked about, takes the results, pipes it through a filter, and so on. So to me, a lot easier to understand perhaps than some of the others. And you can obviously, as you see in that kind of top example, mix and match, right? So we're taking it and piping it through a summarize with a kind of a single sort of call. So definitely some interesting material. If you have questions about it, let me know. I'll be glad to try to add additional color. Moving on to deliverable 4. Which also centers on grouping, indexing, and iteration. Let's get myself back over here a little bit. So the scenario, you're extending your examples, so you want to support some frame data structures. You're interested in working in financial applications, so you want to take a look at some stock prices in the context of frames and allow you for a quick comparison between individual stocks. So you're basically trying to align stocks side by side that may have been stored in a sequential fashion. So for this assignment, you're to take the GAFA stock prices, that's Google, Apple, Facebook, and Amazon, and you're going to have two submissions in this fourth deliverable. First is using Python. You want to read all 4 stocks and associated attributes into separate columns for each of the stocks, and then separate the columns for each stock into the same data frame. So you basically want to sort them so that for a given day you have the same stock or different columns for each of the stocks. So you're turning it from row-wise to column-wise orientation in your sorting, so to speak. And so you basically have to do some reading, some filtering, and then you need to do some kind of mashup to recombine them together. And you're going to do that in Python. The submission in this case will be your source code and plain text written to perform this activity and associated input and output. For the second submission, you'll use something in R, and you'll go out and find some stock prices per day using your favorite search engine to determine the correlation covariance between it and the related stock prices from similar dates between Amazon, Facebook, and Apple. For this second submission, you're to use R. Use the input file for the first submission as your input, and you're going to essentially augment it with something from another query. And basically it's the same sort of thing. You're going to submit your R program in plain text form, which is .r, right? That's what plain text means. And just like .py is your Python or whatever the appropriate notebook format is if you submit a notebook. Here's the rubric that you'll be using for that assignment. Basically, as always, shoot for the mastery column over here. The key things that generally differentiate it is after the initial sort of blurb, it tells you use Python to read the data in Python. That's reading a data frame. But then include significantly more error checking to logic to determine if the data was read incorrectly. That's going to be things like potentially counting rows, looking for null values, checking for exceptions, errors, and so on. The second item, use Python grouping function to group the data together for analysis. Again, includes significantly more error checking, logic to determine if the data was read correctly. You can kind of do some of that potentially by doing some analysis and so on, but document what it is that you do, or have comments inside of your codes explaining that it is error checking that is what you're doing. And then inside of R, similar sort of thing, read your favorite stock price into R, use the R programming language to read data of Amazon, Apple, and Facebook into R. So you're only doing, you're not doing Google for this particular exercise. Includes significantly more error checking logic to determine if the data was read correctly. So similar sort of concept. Don't just do it plus do some defensive coding or validation that it looks like it may be right. And it may be based upon maybe the number of rows is a certain thing, or the number of columns, or maybe there's no null values, or whatever. I'll leave it to you. Calculate the correlation and covariance of all the stocks, include significantly more statistical diagnostics, such as, and here we give you a list of things that you could do: min, max, standard deviation, median, as well as the correlation and covariance. And with that, you're in pretty good shape for deliverable 4. So, as always, if you have any questions, let me know. That's what I'm here for. If you have them ahead of time and potentially can't join at this time, feel free to send them to me in an email, text, whatever, and I'll try to address them during the live sessions. And as always, stay safe. Let me know what I can do to help. That's what I'm here for. I'll talk with you on Wednesday.